We're going to cover a problem in extending modules in Python. So come to the course website at CHE263 at the APMonitor.com website. And here I'm just going to scroll down to the homework on the right. And then if you come down here to homework number 13, this is going to be the homework in PDF form. But if you want to just download these files right here, right next to it, you'll download the homework 13.zip. And then you'll need to extract those files as the first thing. Come to your downloads or wherever it stores your downloads. And I'm going to copy this to the desktop, but copy it somewhere where you can write files. Okay, so I'm going to extract that, and then I have this folder, the IPython notebook, a data file, and then a units.py file. If you just open this up, right-click it, edit with Notepad++ or some other text editor, you can see the units.py. We're going to extend this module right now. So we're going to load it and then extend it. Then for the second problem, we'll do work with this YAML file and create a new class. Okay, but we're just going to do the first problem. The next video will be the second problem. IPython notebook. Go ahead and open that up, and then we'll go ahead and go to our desktop, and then go to homework 13 or that folder that you just downloaded, and then we're going to open up this IPython notebook. The first thing that we're going to do is just look at units.py from the Python notebook. Okay, so this file should be in that same folder where the IPython notebook file that we're working with, this file, and then we want to show the contents of that file by typing percent and load and then units.py. Okay, when I run that, then I can see this. I have some 4 different functions and just a couple of constants here for unit conversions. Okay, it didn't run this, it just is displaying it. Okay, here in my IPython notebook. So we want to extend units.py module in a new ext units.py file with the leading line from units import all. Okay, so we're going to use that to basically load all of this content that we had before, and then we're going to change 2 of the functions and then add 2 additional ones, and then we'll test the conversion functions. Okay, so what we can do here, if we come back to our Python notebook, we can just create a new, let's see, we can do a new text file. Okay, and then if I edit this, I can do ext units.py. Okay, and that's going to make a new Python file that then I'll store in this same directory. So the first thing that I want to do is from units import all. And normally we don't want to do this because there's some namespace conflicts, but when you're going to be extending a module, we're not going to edit units.py, but we're going to extend units.py, create a new function that extends it. Then you can, this is OK practice, where we're extending it. We want to include all of the functions that are there, maybe override them with some of our own. Okay, so what we want to do now is go ahead and define a new function. So before in units.py, actually let me just go ahead and go back here. We had 273.2, but just a couple extra, maybe 1 extra significant digit on that. Let's do 273.15. Just make it just a little bit more accurate. Okay, so what I can do is I can just copy these that were there, and then come in here and go ahead and paste them. Okay, and then when I put 0.15, it's going to basically replace the functions that were in units.py with these new functions that are in ext out of our units.py. Okay, and then I'm also going to create 2 new ones as well. I want to convert from Fahrenheit to ranking. Okay, ranking is just absolute scale for Fahrenheit. So I have temperature in Fahrenheit coming in, and then in order to get to ranking, then I need to just add, I'm going to add 459.67 degrees. So absolute 0 is negative 459.67 degrees Fahrenheit, or 0 on the ranking scale. And then I also want to go from ranking to Fahrenheit, and I have a ranking value coming in, and then minus, and in this case it's 459.67. Okay, so I've saved, so I've added, in here I've added new functions, and then here I this is an override of existing functions. Okay, so I've done both of those by extending this in this new ext units, and then if I click File and then Save, then it's going to save it. And if I come back into my come back here, I see this ext units.py that was saved. Okay, so now I'm going to come back to my this problem now, and so now I want to import ext units as, I'll just do UTS, just shorten the name a little bit, and then when I want to run it, let's say I have my temperature is equal to, in Celsius, is equal to 0, okay, 0 degrees Celsius, and then I want to get a temperature in Kelvin. And so in order to do that, I'll use the UTS dot Celsius to Kelvin, and I'll convert TC. Okay, and then I'll also do that for Fahrenheit, and so let me go ahead and do the Fahrenheit first, and then the ranking last. Okay, Fahrenheit. Okay, so that's going to be C to F. We had one of those functions, and then we have the Kelvin. Okay, and then the last one is ranking, but we don't have C to R, so we've got to do C to let's see, F to R, Fahrenheit to ranking, and then put in the temperature in Fahrenheit instead. Okay, and then I'll print. Let me print Fahrenheit. I'll also print the Kelvin and the ranking. Okay, so use the 273.15. I overrode that function, and then also extended the module with the Fahrenheit to ranking as one of those. Okay, so there's all of the in degrees Celsius, that's the freezing point of water, in Fahrenheit, Kelvin, and in ranking. Okay, so let's go on to the next one now. So we've already imported the ext, or the extended units module, but we want to write a new function that's going to allow us to compute the ideal gas pressure. Okay, so to do this, we're going to just define a new function, p ideal gas, and I have two arguments. One is the temperature, and then also temperature units. It's going to be a string. And so the first thing I'm going to do is just convert to uppercase. So in case my temperature units come in lowercase, I'll just convert that to uppercase, so I have to have fewer if statements below. So then if my units equal Celsius, for example, I can have single or double quotes there. Then I'm going to just have the UTS dot C to K. Okay, and I already had loaded in the extended units module, so I don't need to do it again there. But let's go ahead and do an else if tu equals r. Okay, and then in this case we have to do 3. I'll do UTS ranking to Fahrenheit. Okay, and then I'm going to do as the next one, I'll do, let's see, that's going to be Fahrenheit to Celsius, and then Celsius to Kelvin. Okay, so there it'll spit out the temperature in Kelvin. So it took a little bit, 3 steps to do that with the ranking. Here I have if temperature units equals, make sure you use the double equal sign, Fahrenheit, then temperature. Okay, so I'm just going to copy these two right here, the last two. Start off with Fahrenheit, and I want to make it over to Kelvin. Okay, and then the last one, and that's else if temperature units equals Kelvin, then I'm going to say, there's no conversion needed, and then else we'll print out a message to the user to say invalid temperature units. Okay, and then we can break or return something else, like return 0, or an error message if we wanted to. Okay, and then let's do just now define number of moles is going to be 1 gram mole. Okay, volume is 1. Just some comments there. And this is going to be meters cubed, and then my universal gas constant 8.314. Okay, and that is in joules per gram mole Kelvin. And then my pressure is then going to be the PV equals nRT times N times R times T divided by V. So just rearrange a little bit, and then we'll return P. And here, okay, so I'm returning here if it has an error, but otherwise I'll return this pressure. It's going to be in pascals. Okay, so let me go ahead and just test this. I'll print the ideal gas pressure 0 in degrees Celsius. Okay, and then I'll also print ideal gas at 32 degrees Fahrenheit. Okay, so and then the last one I'll do is going to be 491.67. And we saw from the last one that all of these are the same temperature. It's the freezing point of water, but this is going to be the ideal gas pressure at these temperatures. Okay, so let's go down. So they're all the same. It converted the units and then gave us the same pressure in all cases. Okay, so that's good. We've finished problem 1. And let me just review what we did. We had this units.py, but maybe something wasn't quite right, or we wanted to extend or have some different functions, override them, but include some additional ones as well. If I go ahead and insert cell below, then I can also load extended units.py, and if I run it, I can see those as well. Okay, and then part B, we just wanted to import it and then do a couple unit conversions, make sure that it was working correctly. So these are the freezing point of water in different units, and then write a function, a new function that uses some of these unit conversions to give us ideal gas pressures. Okay, and then for problem 2, we'll move on to that one next. I'm not going to show it in this video, but just look for the next one, and that'll be creating a new class for computing thermodynamic properties.